Welcome to today's video on Unit 3, Part 2. We're going to start out by talking about the binomial theorem. So recall some definitions. Recall that 0 factorial is equal to 1. And recall that any factorial, it just means you multiply all the numbers up to that number where n is in the whole numbers, right? So to simplify a factorial, for example, n minus 1 factorial over n plus 2 factorial, remember you want to simplify the larger one. So in this case, we're going to simplify the n plus 2 factorial. That can be n plus 2 times n plus 1 times n minus 1 factorial. So notice the factorials will cancel, and you're left with 1 over n plus 2 times n plus 1 times n. And when you multiply that out, you're left with 1 over n to the third plus 3n squared plus 2n. Final answer. All right, so to do the next one, 3n plus 1 is the bigger one, so we'll simplify that. So it becomes 3n plus 1. 3n minus 1, and then 3n minus 2 factorial, all over 3n minus 2 factorial. So when you multiply this out, you get 27n to the third minus 3n. All right, so binomial coefficients. So coefficients, remember, are the numbers in front of the variables. So when we do the binomial theorem, we're going to get coefficients. And the coefficients we can find by using what we call the combination formula, or n choose r. And here's the formula for n choose r. It's n factorial over r factorial times n minus r, where n, r are both in the whole numbers, and n must be greater than or equal to r because it has to do with probability. So you can't choose more things than you have. N is what you have, r is what you're choosing. So for example, 4 choose 0 would be 4 factorial over 4 factorial 0 factorial. The 4 factorials cancel out, and 0 factorial is 1, so it's just 1 over 1. 4 choose 4, 4 factorial over 0 factorial times 4 factorial. Notice they cancel out again. You still get 1. 5 choose 3, 5 factorial over 2 factorial times 3 factorial. So that means it's 5 times 4 times 3 factorial over 2 factorial, 3 factorial. Notice they cancel out. 2 factorial is just 2, so it's 20 over 2, which is 10. So let's do some general coefficients, like n choose n. So that's going to be n factorial over 0 factorial n factorial, because n minus n is 0. So notice they'll cancel out. So anytime you have n choose n, or the same number choose itself, then you're always going to get 1, because there's only one way to choose all the objects. N choose 0, so n factorial over n factorial 0 factorial, because n minus 0 is n, so that cancels out, and you're left with 1. So there's only one way to choose 0. N choose 1, so that's n factorial over n minus 1 factorial 1 factorial. Well, n factorial is n times n minus 1 factorial. So when you simplify, notice it just gives you n. So if you say 5 choose 1, then there's 5 ways that you can do that. So n choose 1 is just n. N choose n minus 1, so you have n factorial over n minus n minus 1 factorial times n minus 1 factorial. Well, n minus 1 is just 1. so it's 1 factorial. So it's going to be n factorial over n minus 1 factorial. And we all saw how that played out in the last one, where it's just equal to n. So if you have 6 choose 5, well then there's going to be 6 ways to do that. All right, so some proofs here with these binomial coefficients. We have n choose n minus r equals n choose r. So now remember, whenever you're doing a proof, whichever side you're going to start with, you're going to write again. So I'm going to start with the left. So n choose n minus r equals, and I'm going to define that. So it's going to be n factorial over n minus r factorial times n minus r factorial. Sorry. All right, so now I'm going to simplify, and keep in mind what n choose r is equal to. It's n factorial over n minus r factorial r factorial. So that's what I want to end up with. That's what I want to simplify to. So here, when I simplify, I get positive r. And then I have n minus r factorial. So notice that is the same as what's up here, so I can just rewrite that as n choose r. All right, number 9 is a little more challenging. I'll start with the left again, since that has more stuff. So n minus 1 choose r minus 1 plus n minus 1 choose r equals n equals, and now this is where I have to simplify. So it's going to be n minus 1 factorial over n minus 1 minus r minus 1 factorial over r minus 1 factorial. And then, hold on, got to extend this out. All right, so then plus, and then we have n minus 1 factorial over n minus 1 minus r factorial, r factorial. So simplifying here, you get n minus 1 factorial over, and then n minus 1 minus, so it's minus r, and then plus 1. So the 1's cancel out, so you have n minus r factorial times r minus 1 factorial plus n minus 1 factorial, and then it's n, and I'm just going to rearrange here, minus r minus 1 factorial, r factorial. Now in order to add these to get a common denominator, so here notice in order to get n minus r factorial and n minus r minus 1 factorial to be the same, I have to multiply by n minus r to this side. So if I get my common denominator, it's going to be n minus r factorial, so that's the biggest one. So I have to multiply this side by n minus r. And then here, r factorial and r minus 1, I would have to multiply this by an r. So it's going to be, the common denominator is n minus r factorial, r factorial. So it's n minus 1 factorial times r plus n minus r times n minus 1 factorial. Now notice they share in the numerator an n minus 1 factorial, so then I can just factor. So it's r plus n minus r times n minus 1 factorial over n minus r factorial, r factorial. Notice the r's cancel out, and when you multiply n times n minus 1, you get n factorial. So it's n factorial over n minus r factorial, r factorial, and that is n choose r. That is n choose r. All right, so that was the proof there. So number 10, here it has an equation using these. So n choose 2, that's n factorial over n minus 2 factorial 2 factorial equals 36. Well, remember to simplify, you want to break down the bigger one. So n minus n times n minus 1 times n minus 2 factorial over n minus 2 factorial 2 factorial. So notice the n minus 2 factorials cancel. So you get n times n minus 1, so you get n squared minus n over 2 equals 36. Then you multiply both sides by 2, so you get n squared minus n equals 72. Move over the 72 to factor. So you get n minus 9 and n plus 8 equals 0. So n equals 9, n equals negative 8. But remember, in these binomial coefficients, the n's have to be whole numbers, so negative 8 is not a whole number. So 9 is the only answer. All right, so then the next one, n minus 4 factorial is less than 7. Well, to figure out the factorials, remember 0 factorial is equal to 1, and that's less than 7. So in order for n minus 4 to equal 0, n would have to equal 4. 1 factorial is equal to 1, and that's less than 7. So it's in order for n minus 4 to equal 1, n would have to be 5. 2 factorial is equal to 2, which is less than 7. So for n minus 4 to equal 2, n would have to equal 6. 3 factorial is equal to 6, and that's less than 7. So n minus 4 equals 3 when n is equal to 7. Now 4 factorial, that's 24, so that's not less than 7, so you don't have to worry about that. So the only numbers that n can be are 4, 5, 6, and 7 in order to make this work. Because remember, you're just looking for the values of n. It's not going to be a range, because remember, n has to be positive whole numbers. So that's why it's only 4, 5, 6, and 7. It's not between 4 and 7. All right. So the binomial theorem. So the binomial theorem is when you expand out a binomial, like a plus b to the power. So in order to get that, it's going to be the sum of the terms where you have the binomial coefficient n choose r, and it's going to be a to the n minus r, b to the r, and you're going to start with r equals 0, because remember, like if you do a plus b squared, it's a squared plus 2ab plus b squared. There's 3 terms, right? So there's always one more term, so that's why you got to start with r equals 0. So how many terms will there always be? There's always going to be n plus 1 terms. What is the binomial coefficient of the first term? It's going to be n choose 0. The second term would be n choose 1. The last term would be n choose n. What is r for the first term? R is equal to 0 for the first term. It's equal to 1 for the second term. For the 7th term, it's equal to 6. So r is always 1 less than the term. So it's going to be the term minus 1. Whereas n is always the power of the binomial. So the last term, it's going to be n minus 1. The last term, r is going to equal, n minus, the last term, r is going to equal n, So if you look at this example here, 5x minus 2y to the 10th, since it's to the 10th power, there's going to be 11 terms. The first term will be 10 choose 0, 5x to the 10th, because remember, the exponent for the first term is always the difference of these two, and then negative 2y to the 0, because the exponent for the second one is always the r value. The last term will be, so it'll be 10 choose 10, and then it's going to be 5x to the 0, negative 2y to the 10th. So notice the exponents just flip around. The middle term, well, if you have 11 terms, the middle term is the 6th one because you have 5 on one side and 5 on the other. So it'll be 10 choose 5, because remember r is always the term minus 1. And then it's going to be 5x to the 5th negative 2y to the 5th, because the difference is 5 and the r is 5. So if you'll notice, when you do the binomial theorem, the power of the first term will always increase by 1 each term, and the power of the second term will decrease by 1 each term. So for example, the first term, notice the n here will be 10, the r would be 0. The second term, n10, r1. The third term would be n10, r2. Fourth term, n10, r3. And then it's 10 and 4, and then 10 and 5. All right, so if you're trying to find a specific term, like in this case, you're trying to find and fully simplify the 5th term of r to the of 3y plus 4 over 3y to the 14th. So that means n equals 14 and r equals 4, because the 5th term, so r is equal to 4. So it's 14 choose 4, and then it's 3y to the 10th, because remember the difference, and then 4 over y to the 3rd to the 4th. And it makes sense because the exponents have to add up to 14. So now you have to expand this out, 14 factorial over 10 factorial times 4 factorial, because it's n minus r times r. And then this is 3 to the 10th, y to the 10th, and 4 to the 4th over y to the 12th. So then you expand this out, 14 times 13 times 12 times 11 times 10 factorial over 10 factorial times 4 times 3 times 2 times 1. And it's 3 to the 10th, y to the 10th. And then I'm going to make 4 a prime number, so it's going to be 2 squared to the 4th, so it's going to be 2 to the 8th. And then y to the 12th. So here the 10 factorials cancel. The 2 cancels with the 14 to give you 7. The 3 cancels with the 12 to give you 4, and the 4 cancels with itself. So notice I should have all prime numbers. So I have 2 to the 8th. I have 3 to the 10th. I have 7. I have 11, and I have 13. And then for the variables, notice the y to the 10th over y to the 12th, that gives me over y squared. And that is the 5th term of this binomial for 3y plus 4 over 3y to the 14th, or 4 over y to the 3rd.